Hi students, this video is on magnetic effect of electric current part 5. In this video now let us discuss the important point, what is electromagnetic induction and its definition. We know from the Oersted experiment that a current produces a magnetic field. The reverse will also be true and a magnet can be used to produce a current. Michael Faraday began to work on this problem in 1825. For 6 years, he experimented with the magnet and coils of wire until one day he threw the magnet down into the coil and observed that a momentary current was produced in the coil. So this is very important observation. For better understanding of electromagnetic induction, the Michael Faraday and Joseph Henry conducted a series of experiments to understand what is electromagnetic induction. Now let us study those experiments. So the experiment one is what? The current induced by moving a magnet. Now let us study this experiment in detail. The experimental arrangement used by the Faraday consists of a coil C of a few turns. A sensitive galvanometer G is included in a series with the coil, and the Faraday's observations in the experiment are: when the magnet is stationary, there is no deflection in the galvanometer, and when the north pole of the magnet is brought towards the coil, a current flows in the coil and the galvanometer shows deflection towards the right. And if the motion of the magnet is stopped, the galvanometer again shows no deflection. Thus the current in the coil flows as long as the magnet is moving. And if the magnet is moved away from the coil, the current flows in the direction opposite to that in the earlier case, and the galvanometer shows deflection towards the left. If instead of north pole, the south pole of the magnet is either brought towards the coil or moved away from the coil, the directions of induced currents in the two cases are opposite. So in case of the magnet is moved faster with the velocity greater than the earlier one, the deflection in the galvanometer is also increases. So these are some important observations made by observed by the what these Faraday's experiment. And from this experiment, Faraday arrived at a certain conclusions. And what are these conclusions? Let us see one by one. The first conclusion is the galvanometer shows the deflection, that is, an induced current flows in the coil only when there is a relative motion between the coil and the magnet. This is first thing. There should be a relative motion between the coil and the magnet. And the second one is the direction of deflection is reversed if the direction of the relative motion between the coil and the magnet is reversed. This is the second conclusion. And the deflection in the galvanometer increases if the magnet and the coil are rapidly moved with respect to each other. That means what? If we increase the relative motion between the coil and the magnet, the deflection in the galvanometer increases. That means what? The current induced in the coil is also increases. So these are the what? The conclusions. With all these experimental observations and conclusions, Faraday formulated the two laws on electromagnetic induction. So whenever the first law is, whenever the magnetic flux linked with the coil changes, or the magnetic field linked with the coil changes, an EMF, and hence the current is induced in the coil. This is known as the electromagnetic induction. And the induced EMF, that is these induced EMF and induced current, those EMF and currents are called as induced EMF and induced current. And the second law of electromagnetic induction is the magnitude of the induced current is directly proportional to the rate of change of magnetic flux linked with the coil. And here it is very important to note that the induced current is not like the one due to an electric cell. In an electric cell, it is the chemical energy that is converted into electrical energy, that is current. But in case of electromagnetic induction, the induced current is due to what? Changing the magnetic flux in the coil. Since to change the magnetic flux or the magnetic field linked with the coil, we have to do the work to cause the relative motion between the magnet and the coil. So it is this work, the mechanical energy is converted into electrical energy. Hence the law of conservation of energy is also proved here. So the now next very important point is how to find the direction of the induced current. For this, Fleming's right hand rule is used. It is also called as a dynamo rule. And for this, stretch the thumb, the forefinger and the central finger of the right hand so that they are mutually perpendicular to each other. If the first or forefinger points in the direction of the magnetic field, the thumb points in the direction of the motion of the conductor, then the central finger points in the direction of the induced current. So in this way you can find the direction of the induced current. So this is very important rule. This we can use to find the induced current.